This will be for the con exercise, inverse functions, graphs, and tables. So just some notes. The inverse of a function will have the same coordinates of the original, with the x and y coordinates reversed. So if the original function had a point 3 comma negative 5, the inverse of that function, you just reverse the x and y coordinates, and now it would be negative 5 comma 3. So the graph of the inverse of a function will be a reflection over the line y equals x. Okay, I just drew a little image here. This would be the line y equals x, and it acts as a mirror when you have both the original function and the inverse function graphed. So I'll show you that real quick. So here on our graph, I drew the line y equals x, and I'm going to plot one of the points on the original. Let's say it's 2, negative 5. So x equals 2, y equals 1, 2, 3, 4, 5. Okay, this point here would be 2, comma, negative 5. And that's the original. Now, if we reverse that and went negative 5 on the x and 2 on the y, 1, 2, 3, 4, 5, 1, 2. Okay, this point here would be negative 5, comma 2. And that would be the inverse. Okay, so notice the line y equals x basically acts as a mirror, because you can see that these points are both the same distance to this line here in pink, y equals x. So if you have a graph of the inverse and a graph of the original, the line y equals x will act as a mirror. Okay, it says the following graph shows function f, and they want to know what is the value of the inverse of f of 6. All right, so this negative 1 right here is not an exponent. That stands for the inverse of function f. So if f of x is the original, this right here would represent the inverse of f of x. So if you recall, if you had something like f of 6, that would be the y value when x equals 6. But for the inverse function, you want to reverse x and y. So the inverse f of 6 is going to be the x value when y equals 6. So that's all we have to find on the graph, the x value when y equals 6. Let's take a look. Okay, so this is our y-axis right here. So this is y equals 6. We trace that to the graph. And then we want to find the x value when y equals 6. So it's this point right here. Tracing it down. It's in between 2 and 4, so it's obviously 3. Okay, make sure you don't choose any points with the hole in the graph. That means the point is missing at that spot. Okay, but you can see the circle or dot is filled in right here, so that's definitely a point. So the x value when y equals 6 is 3. Okay, so here we have a graph of y equals f of x. And they want to know which of the following shows y equals the inverse of f of x. All right, so you can still use the mirror method if you want. Okay, if you have a line y equals x, this graph here will be a reflection. So it's going to be something like that, okay? It's hard for me to draw the exact reflection. All right, but the graph is going to be something like that. But really, since it's multiple choice, there might be an easier way, and all you want to try to do is reverse the x and y intercepts. Okay, so you can see here on the y-axis, the y-intercept is 3. Okay, it's in between 4 and 2. So now on a new graph, on the inverse, the x-intercept is going to be 3. All right, and here on the original, the x-axis, the x-intercept is right here between -6 and -4. That's going to be a -5. Okay, on the new graph, instead of this being the x-intercept, the y-intercept is going to be -5. So if we look at our multiple choices, it should meet this criteria right here. Let's take a look. Okay, answer A has the y-intercept at 5. We want -5. Answer B, x-intercept +3, y-intercept -5. That could be correct. Answer C, they have the x-intercept at 5. That's wrong. Answer D, they have the x-intercept at -5. That's wrong. Okay, so the only answer is B. All right, the following table shows a few inputs and outputs of h of x. What is the value of the inverse of h of 9? All right, so if this were the original function, h of 9, you would have to find the y-coordinate when x equals 9. But for the inverse, that is reversed. So now we want to find the x value or the x-coordinate when y equals 9. Okay, this is x and this is h of x. So these right here are basically the y-coordinates for the h of x function. All right, so what's the x value when y equals 9? Well, these are the y's. If you go to y equals 9, the x-coordinate for y equals 9 is going to be 37. So that's your answer. So just enter that in the box.